So one more video for lecture 3 here, and this finishes up chapter 2 for us in the Hibbler text, and most other texts as well. So we've just talked about the dot product here. Let's work an example. Pretty straightforward example. I've got let's just do this. Let's say I've got X, Y, and Z, and we'll say that I've got some sort of a ring attached to the origin here. I guess you can't see that. There we go. Got some sort of a ring attached to the origin here, and I've got two vectors applied to it. This one is a little bit in the Y, but very much heavy in the X and Z direction. We'll call this vector A. And then a smaller vector, we'll call him vector B. And we're just going to say find the resultant force and the angle between vectors A and B. So I've applied two vectors to this object on the origin here, and we'll say that vector A is known. It is 18I plus 1J plus 30K, and we'll say those are pounds. And we'll say that vector B, looks like my blue pen's about to give out on me. I've got other pens here, just don't know if I got a blue one. Let's say vector B here is, again, a little smaller. We'll say 2I plus 3J plus 6K, and those are pounds. I've got a green pen. Hopefully that works okay for us. Now, if this was an actual problem, let's say maybe instead of the vectors, maybe they gave you the magnitude and angles and or positions, where you'd have to write position vectors and you'd have to construct these in components, which we've already done some examples like that. So you can do that. Just for simplicity's sake, we're really focusing here on just making sure you understand how to add vectors together. I don't think we've done that yet in 3 dimensions. And then let's look at an angle between two vectors using the cross product. Using the dot product. So if we start with the resultant first, right? So what are we looking for? We're looking for the resultant vector. That's going to be where I add the vectors together. And so what I can do then is I can just say, well, the resultant's going to be A vector plus B vector. And so what I can do is I can take, that's going to be resultant in the X plus resultant in the Y plus resultant in the Z. And so what I can do is I can combine the components from each of these in the X, Y, and Z directions. This is L3. This is going to be page 5 of something. I'll see if I've got some other blue pens for future videos, because that seems to show up the best. Let's tough it out with the green pen for now. So, resultant in the X direction is going to be AX plus BX. That's just going to be 18 pounds. No, 18 pounds plus 2 pounds. They're both positive. 18 plus 2, so I'm going to have 20 pounds. RY is going to be it's going to be AY plus BY. You don't have to write that out if you're comfortable with it. That's going to be 1 pound plus 3 pounds. Why? Because that's the Y components here. It's going to be 4 pounds total. RZ, just going to add the Z components of those guys. That's going to be 30 pounds from vector A and 6 pounds from vector B, 36 pounds. Okay, so the resultant, pretty simple, just adding those components together. They're all positive in this case, so we don't have to worry too much about signs. It's going to be 20 in the I direction plus 4 in the J direction plus 36 in the K direction. It's always wrong if you don't put units on it. We're engineers, not mathematicians. We have to have units. If there are units, make sure you put them on there. We've crashed Mars rovers for less. In our line of work, units kill people. It is always wrong if you do not put appropriate units on it. That's our resultant force. They didn't specify magnitude and direction angles. Easy enough to find if we wanted to. But it didn't ask for it, so we're not going to. We're just going to leave it IJK components and call it good. Now, the problem, though, did ask for the angle between the vectors. How do we find the angle between the vectors? Well, we said earlier that the dot product, A dotted with B, is not a bad way to find the angle between them if you know the magnitudes and if you can find the dot product. Well, how do we find the dot product? We said, well, we went through and did this derivation where you can take AX BX plus AY BY plus AZ BZ. That sum will give you the value of the dot product. And if you know the magnitude of the two vectors, which we can find, then the only unknown then becomes cosine theta. So, all right, so if I look at this and say, okay, well, I know the x, y, and z components of these three. So I've got one equation right now with three unknowns because I don't know these two magnitudes, and I don't know theta. So I've got one equation with three unknowns. So that means I need other equations to solve this. I need at least two more equations. Well, the magnitude of A, we've said multiple times, is you're going to take the square root of the components. And it's going to be, for A, that's going to be 18 pounds squared plus 1 pound squared plus 30 pounds squared. I'm going to let you pause and get a number and come back. Got a number? I have 35, and you've got pounds get squared and then the square rooted. I've got 35 pounds is the magnitude of A. The magnitude of B, you can write as B without a hat, or you can write it B inside the brackets. Square root of 2 pounds squared plus 3 pounds squared plus 6 pounds. If you need practice, feel free to pause, get the number, come back. I'm going to go ahead and write it out here. I've got that is 7 pounds. Okay. I'm going to bet if you find this magnitude of this vector, it is not going to be 42 pounds. I could be wrong. You can't just take 35 plus 7 and say, oh, it's just 42 pounds applied to this thing. I'm going to bet this is not 42 if you find its magnitude. I'll leave that to you to find out in your own time. But because what we are looking for is theta, the angle between these two vectors. Notice I've got now one equation, one unknown, because I know the x, y, z components of both vectors. I now know magnitudes of A and B. Cosine is the only unknown. So theta is going to be the arc cosine minus 1 AX BX plus AY BY. You can plug in numbers here if you like. I, out of habit, tend to not plug in numbers until I do all my algebra. A lot of times these numbers are pretty easy because they're just a couple of figures, but a lot of times the numbers get kind of cumbersome. It might be a bunch of decimal points. You just get tired of writing them. This is exact, right? So I can just plug these right into a calculator as is. I'll let you go ahead and do that again. You've got values for those vectors right there, and you've got magnitudes for the vectors here. So you can plug those in, run your calculator, find the arc cosine. I have written down over here that it is about 26.6, essentially 27 degrees. So these are the two things we're looking for: resultant and the angle between. And we're going to call that lecture 3. So it's going to be page 5 of 5. All right, guys. We'll see you for the next one. And this should get you started. If you're in my class, this gets you started on the Chapter 2 homework if you haven't already. I hope you already have, because it's going to be due pretty quick.